What is the frequency of a photon with a wavelength of 1055 nanometers? So the formula is C equals nu times lambda. C is the symbol for the speed of light. Nu is the Greek letter, which is the symbol for frequency, and the Greek letter lambda is the symbol for wavelength. The problem is asking us to solve for the frequency. So what you need to do is divide both sides of the equation by lambda, so that lambda cancels on the right side and your equation becomes frequency equals speed of light divided by wavelength. So we know that the value for the speed of light is 3 times 10 raised to 8 meters per second, divided by the given wavelength, which is 1055 nanometers. But before we plug that into our equation, you need to convert nanometers to meters because the speed of light is in meters per second. So we have 1055 nanometers. 1 meter is equivalent to 1 billion nanometers, or 10 raised to 9 nanometers. So nanometers will cancel, and this is equal to 1.055 times 10 raised to negative 6 meters. So this will be our wavelength in meters, and we plug that into our equation. So divided by 1.055 times 10 raised to negative 6 meters. So meters will cancel out, and the unit for wavelength, for frequency, would be per second. So 3 times 10 raised to 8 divided by 1.055 times 10 raised to negative 6, that is equal to 2.844 times 10 raised to 14 per second. Or you can write this as 2.844 times 10 raised to 14 second raised to negative 1. Or you can write this as 2.844 times 10 raised to 14 hertz. Second raised to negative 1 is also called hertz. And this is the answer to the question.